Hi there, this is Penelope. This is a short video on the intuition behind maximums and minimums when we're using calculus to find them. These are the official definitions, and yeah, they look a bit fancy, but if we think about what they're saying, then they're okay. Now, the first one, the absolute maximum. When we talk about the absolute maximum, what we're doing is, say we've got a function like this, and we're talking between, say, here and here, and that's C. What we're saying is that at that point C, the value of the function is higher than anywhere else. So we can't find this by calculus, but what we can do is substitute in the value of C to see if it's maybe higher than at here. Now, a local maximum we can find by calculus. This is a local maximum. And it's the idea of the tallest building in Petone is not necessarily the tallest building in the country. See, here, the function is actually taller here, but this is the tallest in the neighbourhood of there, and we can find this by calculus. And the same applies to the minimums, the absolute minimum. So we've got our function that goes like that still. Now, if I make it right, say if this is C here, the value of the function at C is lower than anywhere else. We can't find that by calculus. If we're talking a local minimum, sometimes you'll see these referred to as relative minimums or relative maximums. Same picture. Oops, Daisy missed. This is the lowest in the neighbourhood. It's a local minimum, even though it's not as low as, say, that one. So it's the lowest y value in the neighbourhood. And remember, these are referring to the y values, or the f of x. Okay, not the x, but the f of x. Have a look at this function. Here we've got, say, an interval from 0 to 1, 2, 3, 4, 5, 6, 7. So we're looking at 0 is less than or equal to x, which is less than or equal to 7. Here we've got a local max, but it's also actually the absolute or global as well, because it's the biggest overall. And if we work out the coordinates of that, it's 2 there and 3.5. So the greatest y value is 3.5 anywhere between 0 and 7. If we look there, we've got a local minimum. It's the smallest in the neighbourhood. That's where x is equal to 6, and where y is equal to, hard to say, maybe about 0.3. This is an interesting diagram because if we look here at 0, I suspect that is about the same. I suspect that that's about 0.3 as well. So maybe the absolute minimum is actually equal to the local minimum as well. In this case, just in this case. Here we've got a whole lot of points. Now, just looking at these, this one is the biggest overall. This one is a local minimum. This is a local max. This is nothing really. This point here, it's not the biggest because we're looking at the y values, remember, and this is another local minimum. So there they are. All this bottom one is also the absolute minimum because it's the lowest than anything. There's a local minimum at 0, but there's an absolute min at x equals 3 as well.